There are three types of bonds which we usually study. And what are those three types? The ionic, the covalent, right, and metallic. So three types of bonds are there, and those three types of bonds are going to be studied in detail. Okay, one thing more which I want to tell you is you can see this 3.1, 3.2, 3.3 and 3.5. These are the topics given in your specification. Okay, so get these topics, check it out. What is the detail in your specification? You will see this. What are the learning objectives for the ionic bonding now? When we talk about bonding, we always reach to a conclusion that there is always a bond, an electron loss, an electron gain, or sharing of electron, like that, right? So what are the objectives for the ionic bond? First of all, the first objective is that describe the formation of ions in terms of loss and gain of electrons. It's an old idea, you know about it. Draw the dot and cross diagram to show electrons in cations and anions. And then know that the ionic bonding is the result of strong net electrostatic attraction between oppositely charged ions. Know and be able to interrupt evidence for the existence of ionic. This is very, very important, and we'll talk about it in detail. You might not be knowing this one because this is a little bit higher, so this is real grade 11. The rest is approximately grade 10. So let us start the definition of the ionic bond. What is an ionic bond actually? So my definition is, it is the bond made first point now. The examiner is interested in this point. So star point 1, loss and gain of electrons okay, between metals and non-metals. The loss and gain of electrons between metals and non-metals. Okay. Second point will be, if I'm writing the second point, so second point will be with the strong electrostatic force of attraction between the oppositely charged ions. Okay. Did you get my point? So now when you're writing the definition is that it is the force of attraction. First of all, its ionic bond is because of the loss and gain of electrons. Okay. And this loss and gain of electron is between metals and non-metals. When a metal is losing electrons, it is becoming positively charged, and when a non-metal is gaining an electron, it is becoming negatively charged. So the positively charged species is called a cation, and the negatively charged species is called an anion. Okay, so here if you can see, sodium is a cation. Here you can see the charge, and it is because of the loss of this electron. Sodium has lost this electron, that's why it is sodium with +1 charge. And chlorine has broken this old relation. One electron is taken by this chlorine, one by this chlorine, so Cl was left like this. Now the cross you can see in Cl is from the sodium, so with the negative charge on it. So you can see that two of the sodiums and two of the chlorides have got together, and you got the dot and the cross structure of sodium chloride. Are we clear? The configuration of sodium is 1s2, 2s2, 2p6 and 3s1. The configuration of chlorine is 1s2, 2s2, 2p6, 3s1, 3s2 and 3p5. Sodium will give this electron to chlorine. The remaining configuration for sodium is like this, and now the configuration of chlorine is with 3p6 now. So both have attained the configuration of the noble gas. One is for neon and the other is for the argon configuration. So electrons are lost and electrons are gained. Keep this in your mind. This was the old definition which we used to do it. Okay? So you should be able to define in this way that a metal is losing an electron which is creating a positive charge on it, and a non-metal is gaining an electron which is creating a negative charge on it. A strong electrostatic force of attraction is developed between the two species. One is cation now, the other is anion now. This is called an ionic bond. Metals and non-metals, loss and gain of electron, strong electrostatic force of attraction between the oppositely charged ions. Are we clear? So what are the examples in your course which you are going to study? You are going to study sodium chloride, NaCl. You are going to study MgO, MgCl2. Okay, you are going to study CaO and CaCl2. You are going to make the dot and cross structure of these molecules. Okay, sodium chloride we have already done for it. Magnesium oxide, magnesium chloride, calcium oxide will do for these ones. One thing which you need to keep in your mind, sometime the examiner is showing C here in case of sodium. In case of sodium, we can see that, hold on, let me remove this. In case of sodium, you can see that they're showing the outermost shell to be empty. Okay, you're not supposed to do that. You're going to show the outermost shell now with 8 electrons. 1, 2, what is left behind. Okay, this will be really appreciated. 8 electrons like this. Okay, with a plus charge outside the bracket. Don't forget to draw the brackets and the charge. So there will be 3 marks for this drawing. Okay, how are the marks classified? 1 mark is for the dots and the crosses, correct ones. Okay, even this is also measured, so keep this in your mind. So when sodium and chlorine dot crosses are correct, 1 mark is for sodium, 1 mark is for chlorine, and 1 mark is for these charges. So you get 3 by 3. And if you make a mistake in this, you will lose individual marks. You can even lose, and even you can lose the whole marks. Are we clear?
Yes, sir.
Okay, now I'm trying to go for magnesium oxide, okay, here. So magnesium is having how many electrons in its outermost? Magnesium is having 2 electrons. So the first shell is 2, then we have 8, then we have 2, okay. This is magnesium. Magnesium will lose these 2 electrons and it will try these electrons or give this electron if there's oxygen in it. So oxygen is having the configuration which is 2 and 6. So oxygen needs 2 electrons, right? So if you draw the shell number 1, shell number 2, shell number 3, and shell number 1 and shell number 2 for oxygen. Now both the electrons will be accepted by this oxygen and you will see them here, one here and one there. So this will make it 8 electrons. Now when you are working on the dot and cross for oxygen, magnesium and oxide, so how will this dot and cross work for you? Let me a little bit zoom in so that we can work on the dot and cross. Okay, now this is the structure of magnesium. It was having 2 crosses, okay. 1 and 2 crosses are there in Mg. This is lost and this is lost. So the condition of magnesium is, put it in a bracket, put all the crosses here, 1, 2, 3, 4, 5, 6, 7, 8. These are all the crosses. Put it in a bracket with 2 plus charge on it. This is magnesium, okay, Mg. Moving on towards oxygen. We'll draw oxygen now. This is the condition of oxygen now. We are having dots are for oxygen, keep in mind, okay. So 1, 2, 3, 4, 5 and 6 dots are there. So oxygen is going to accept the electrons and this will change into O with cross dot dot, 2 dots here, dot and a cross, dot and a cross. This is oxygen, now called oxide with 2 minus charge. Now both the ions are ready. In the third step, what we are going to do, we are going to bring those ions together close to each other, okay. So bringing those ions close to each other, let me just reach to the page. Where did I leave? Yeah. Okay. Now I will draw these 2 ions together, bringing them close to each other. I'll draw them here. So this will be the dot and a cross now. Together, okay, draw, let them draw here. This is for magnesium, this is for oxygen. Magnesium is 1, 2, 3, 4, 5, 6, 7, 8 and oxygen is 1, sorry, magnesium should be with the crosses, okay, not with the dots. So we have crosses for magnesium, 1, 2, 3, 4. I'm showing the shell which is left now, okay. This is Mg and a 2 plus charge, and for oxygen we have now 1, 2, 3, 4, 5, 6 with a cross, and with minus 2 charge. So now I've done it according to the definition. Magnesium is a metal which is losing 2 electrons, creating a 2 plus charge on it, creating a positively charged metal cation. Then oxygen is a non-metal, accepting 2 electrons, creating 2 negative charge on it. It's a metal, non-metal anion. Then a force of attraction between these 2 is developed. This is called the ionic bond. Okay. This is the definition which we are done now. So I'm winding up here on the definition.